Hello everyone, and welcome back to Mr. Anderson's Algebra 1 lessons. Today we're going to be reviewing how to graph a quadratic equation by hand. Now this is assuming you know a few things before we start. That's assuming that you know to find the x-intercepts of an equation, and that you do by setting y equal to 0 and factoring. That's also assuming that you know how to find the y-intercept of a quadratic equation by setting x equal to 0. That's assuming the vertex with the vertex formula. So the x-coordinate of the vertex would be negative b over 2a. And the y-coordinate of the vertex is plugging that back in to your original equation when you find that. So you would get 4 coordinate points, 2 for the x-intercept, 1 for the y-intercept, and 1 for the vertex that you would plot on your graph. So this is the information you need to know before you do this process. So I have for me here a lovely little graphic where I would do my work and show my graph at the end, and I'm going to doing that for you right now. So they give us the equation y equals x squared minus 4x plus 3, and they want us to find the x-intercept. So I'm going to do that by setting it equal to 0 and factoring. So I'm going to factor first, set it equal to 0. You have x squared minus 4x plus 3. And I'm looking for two numbers that multiply to 3, but they add to negative 4. And that is going to give me negative 1 and negative 3. So this is factored form now. And now I'm going to use that to solve for x. And I like to separate my two little binomials and make a little mini equation to solve for x here. On this side you're going to add 1 and find that x equals 1, and on this side you're going to add 3 to each side and find that x equals 3. And so the ordered pairs for your two x-intercepts are 1, 0 and 3, 0. And if you would like, you can take these two coordinate points and plot them on your graph over here. This would be the first x-coordinate, and this would be the second x-coordinate at 1, 0 and 3, 0. Alright. Next you're going to find the y-intercept by plugging in 0 for x. So you take your original equation, plug in 0 for the x, and you find that this term equates out to 0 and 3 is the remainder. So your y-intercept is at 3, and the ordered pair for that is 0, 3. So you would go up to the y-axis and plot your y-intercept at 0, 3. And so now you have 3 coordinate points there. And finally, for the vertex, you need to know a and b from your quadratic. A is the number in front of the x, so the leading coefficient here. That would be 1, so a is equal to 1, and b is the number in front here, the middle term, negative 4, and I can use that to find the x-coordinate of my vertex here. So the x-coordinate is equal to negative, you have negative times negative 4 over 2 times 1, and that is just 4 over 2, which reduces itself down to 2. So now to find the y-coordinate of the vertex, you take that 2 and plug it back into your original equation that you are given up here. So doing 2 squared, might get 4, 2 squared is 4, minus 8, 4 times 2 is 8. So 4 take away 8 is negative 4. And negative 4 plus 3 is negative 1. So negative 1 of my vertex. So my ordered pair for the vertex is 2 and negative 1. So now that I have that vertex, I can plot that over here. X equals 2, y equals 1. There it is. We got a little line of symmetry here that goes through. Now I like to draw the mirror point, or the symmetrical point to this one. The distance is 2 between this, so that means the other point would be over here. That is the same distance. So now that I got these points here, I can just draw my little graph the best I can. And that's a generalized picture. It's not perfect, but if you were trying to figure this out just for fun, or you needed to do so quickly on a test, and they just give you this on a piece of paper, you would do that. And this is sufficient enough to graph a quadratic equation. And so I hope you enjoyed this little mini lesson. And with that, I wish you good luck and peace out.